Ever watch a robot try to open a door? I mean, it looks kind of clunky, right? You'd think it'd be simple for them, but
Yeah, it's a good example of where we're at with robots, I think. We spend so much time on the software side, all the
yeah,
programming and algorithms, but
we forget about the body.
yeah, exactly. Like, we haven't quite cracked how to make those physical movements as smooth and adaptable as well as us, I guess.
And this new research from King's College in London that we're looking at today, well, they're trying something totally different.
Yeah, totally different approach.
And they think it could be the key.
They're talking about using pressure.
Pressure, okay, now you've lost me. And air pressure. How,
I know it sounds kind of out there, but
help me understand.
so we tend to think of robots as needing these really precise instructions, right? Every movement is controlled by software, by electrical signals.
Right.
But what if we could take some of that control away from the software? What if instead of micromanaging every tiny movement, we could offload some of that to the hardware itself?
Okay, so you're saying let the robot's body handle some things on its own.
Exactly. Give it more autonomy.
And this pressure idea, this is how they make that happen.
It's one way, yeah. And it's particularly interesting when you think about soft robotics. Those robots made with flexible material.
Like the ones designed to mimic octopus arms or whatever.
Yeah, exactly. See, the problem is integrating electronics into those designs has always been a nightmare because traditional electronics are so rigid.
Right, they need those solid circuits and all that.
Exactly. So it's always been this kind of mismatch of technology trying to force something rigid into something that needs to be flexible.
So with this new approach, are you saying they're ditching the electronics entirely?
Well, not entirely, but they've come up with a really clever workaround.
Okay.
So they're using a special type of circuit. It's called a reconfigurable circuit. And it basically uses a valve that can open and close depending on changes in fluid pressure.
So there is fluid involved. I knew it. Okay, I'm picturing pipes and valves and like liquid being pushed through. But how does that translate into, actual instructions for the robot to follow?
Okay, so imagine a bunch of little chambers, right? And these chambers can either be filled with fluid or empty depending on the pressure. Now, if a chamber is full, that represents a 1 in binary code. Empty chamber, that's a 0.
Oh, okay, I see where you're going with this.
So by changing the pressure, they can control which chambers are filled and which ones are empty, and that creates a kind of binary language.
So it's like instead of electrical signals sending ones and zeros, it's the pressure itself?
Exactly. And the robot's hardware is designed to respond to those pressure changes.
Wow, that is so clever. It's like giving the robot a whole different way to sense and respond to its surroundings.
Yeah, it's a completely different approach to robotic control. And what's really exciting is how well it lends itself to soft robotics.
And right, because now you don't need to worry about those rigid circuits and components.
Yeah, exactly. It's a much more natural fit for robots that are designed to be flexible and adaptable.
It's funny. It's almost like how our own bodies work in a way.
Oh, how so?
Well, like take our heart, for example. It beats without needing our brains to constantly tell it what to do. It just sort of knows what to do based on changes in pressure and blood flow.
That's a really great analogy, and it highlights the elegance of this approach. It's about creating systems that are inherently responsive and efficient.
So it's not just about making robots smarter. It's about making them more...
More organic, more in tune with their environment.
Exactly. And I have to imagine this opens up a whole world of possibilities for what robots can do and where they can go.
Oh, absolutely. This is about way more than just robots getting better at opening doors. This has the potential to revolutionize the field.
Like how so? Give me some concrete examples.
Well, for starters, think about all the energy and processing power it takes to control every single movement a robot makes. Now imagine we can offload some of that control to the hardware itself.
Freeing up the robot's brain to focus on other things.
Exactly. It's like suddenly you have all this extra computing power to play with. You can create robots that can handle much more complex tasks, make decisions, learn and adapt in real time, things we can only dream of right now.
And it's not just processing power we're talking about, is it? This tech could let them go places and do things that were impossible before.
Exactly. I mean, think about environments that would fry ordinary electronics, like inside a nuclear reactor, for instance, or a burning building, even underwater.
You could send robots in to handle hazardous materials, make repairs, gather data.
Exactly. Situations that are just way too dangerous or unpredictable to risk sending humans into.
Right now, that's fascinating. Or what about places with unreliable power grids?
Exactly. Think about disaster relief, for instance. Robots that could be deployed immediately after an earthquake or a hurricane. They could navigate all the debris, the unstable structures, and they wouldn't be dependent on any external power source.
Wow, that's incredible. So they could be searching for survivors delivering aid, all while the infrastructure is still a mess.
Exactly. It could completely change how we respond to these kinds of disasters.
So what's next? Where do we go from here? Are scientists already building these things?
Yeah, they're already taking it to the next level, moving from those small-scale lab experiments to larger, more complex robots.
So are we talking like industrial robots? The kind you'd find on a factory floor?
Yeah, potentially. Or those sophisticated rescue robots we were just talking about. Imagine robots monitoring power plants, inspecting underwater pipelines, even exploring the depths of the ocean.
I mean, it sounds like this could be the start of a whole new era of robotics.
It really could.
One where robots are more than just intelligent machines. They're adaptable, resilient, able to function in environments that would have been unthinkable before. It's exciting and a little bit unnerving when you really think about it.
It definitely makes you think about what it means to be a robot and I guess what it means to be human in a world where robots are becoming this capable.
It's a future full of possibilities, that's for sure. So to everyone listening, the next time you see a robot, take a second and think about not just the software running in the background, but the potential of its physical form. The future of robotics might just be powered by something as simple and as elegant as pressure.